Hello, I'm Robert for Doomsday Debunk on Facebook, where we help people who get scared of various things by just presenting the truth as it is without any sugarcoating, just as it is. So this time I'm going to talk about when a thing is going to peak X, which is a thing that people worry about. They worry about how we might run out of resources, that there might be a point where we have no cobalt or no lithium or no oil or coal or something. So, as we'll find out, actually, this isn't a thing that we need to worry about at all. But let's go and have a look and see why. And there's so many pages that make a big thing about it. So, first of all, the thing is that as we transition to renewables, we are using less fossil fuels. And we have to do that anyway for in order to deal with global warming. So this is a graph that Carbon Tracker did. Oh no, this is Shell Sky. This is the Shell graph. So Shell Oil, they have this idea of us peaking in the late 2020s, and then the renewables going up like that. This is the Shell Sky, which is assuming that we do go ahead with our climate change pledges and everything works. And I think that might be, it's compatible with the 2C level, which is not very ambitious, but it's more ambitious than we are on at the moment. We're at 2.9C, and I think it's not too unlikely we get onto that path at least. And BP came to a rather similar conclusion, but Carbon Action Tracker thinks it's going to be rather earlier, and they think it's 2023 that might be the point at which we peak with fossil fuels. And they warn about the risks to investors. The 2020s will be the decade of fossil fuel demand peaks as one bastion after another is stormed and overwhelmed by the rising renewable tide. This will inevitably lead to trillions of dollars of stranded assets. So they're warning these fossil fuel companies that, especially if they continue, for instance, investing in drilling for new oil fields, and if we've already got enough, then all those extra assets of all the new oil drill, the new wells and the drilling infrastructure and so on, it's possible it might never be used. So that is a risk for some of the fossil fuel companies. So in any case, that's a risk for them. And the good news is that there's plenty of fossil fuels in the ground. We're not going to run out of them. And if we have a look, these are the different amounts that are. There's vast amounts of coal, especially, and oil and gas, and then once you include unconventional shale oil. So, for instance, proven natural gas reserves are equivalent to 53 years of production at the present. Natural gas. What else do we have? That's about the strong growth in renewables. I know I've got the coal there. Where's it gone? Just find the coal. Enough coal for 150 years, and enough shale oil for 1,300 years. It's vast amounts of shale oil, but we're never going to use all that. But here we are. Coal. So that's enough coal for 140 years. And there we are, shale oil for 1,300 years, and 53 years of recoverable conventional oil, and gas 53 years. So there's no way that we're going to run out of that, because we're heading off towards more and more renewables. And these are the, I think, like I said, BP or Shell. But they're rather pessimistic. I mean, so if you look at this is for the UK, and that's the band. The fossil fuel prices are not changing. If anything, they increase slightly. And so that's the band for the high and for low prices for fossil fuels. And this is what's happened to the renewables. As you can see, onshore wind and solar PV already are they're projected they already are competing at the very lowest price level with the fossil fuels at the low. And this is in the UK, where the solar power especially. So we're not the brightest or most sunniest of countries, and yet we're already competing down there, and then we expect it to go right down. And they're going faster than any other fuel in recorded history. This again is the BP, I can't remember which that is, but they did this projection. So this is the growth. The yellow is the growth of nuclear power, and that was the most rapid growing early stages. Grew very, very quickly at first, people were very, very keen, but then it kind of leveled off, and it's fixed and it's even gone down a bit at a few percent. That's the percentage of the total. The renewables gone about the same amount as that, like the early days of nuclear, but now this is for their Ducey path, and this is another more gentle path transition. And even that, look how it's soaring. And we're probably going to go even faster. We're going even faster than that with 1.5C. So and it is feasible, because I'm not sure if I got that here, but the power stations are getting towards the end of their life. The power stations we have now, and many of them will be reaching the end of their life by 2050 anyway. So it's just a case of replacing the fossil fuel power stations. Of course, many are already reaching the end of their life now or in the near future. And as they phase out, to replace them by renewables, instead of replacing them by fossil fuels. So when people talk sometimes about the great expense of all these renewables, they are missing out this point that we have the great expense of all the ongoing fossil fuel plants. And they might say eye-watering numbers about, is it something like we need a new nuclear power plant every day or something, one of them said. But they would need the equivalent for fossil fuels. So it's hardly makes any difference whether you're replacing it by fossil fuels or by the renewables. So we certainly can transition, and we can, and then you can recycle renewables. We now have fully renewable recyclable solar panels. And another thing, for instance, in the oil industry, we have all these oil tankers, huge oil tankers, that are going back and forth carrying the oil around. Once you've got renewables, you don't need to carry anything across the sea because it's got no fuel. So you don't need those oil tankers. And those oil tankers, I think it's 15 years or something, their lifetime, so they have to be recycled eventually. All that metal in the oil tankers is not needed anymore if you go to renewables, and can be recycled into wind turbines or whatever. So you have to think about this as a whole picture, and not just think it's all coming from scratch. As we build up, as the renewables, as the fossil fuel infrastructure reaches the end of its life, then we can be building renewables. Now if we do the renewables by say 2030, then we have to speed up on that. But if we're going for zero emission for 2050, then it's not going to be hard. And here the UK emissions, see how they're rapidly falling. And that was our original target. We're now going to go down to zero by 2050. And this shows how China is the key. And this shows this is the world's largest solar farm, which is coupled with a hydro plant there. And that is a very, very good synergy, because the hydro plant is you can use it for power at any time of day or night. The water builds up when you don't want power, and then you let it out when you do want power. And so it's very good for balancing solar, which you only get in the daytime, and that can be at night. And so you can hugely increase the amount of power you get from a hydroelectric plant by adding solar, and all the solar power you add is added to it without any curtailment. And this more than doubles the output from a hydroelectric plant. And then you also have the idea of you just build, so for instance, if you wanted more storage, more hydro storage, and if there's a nearby hill or mountain, you can put a reservoir on top of that, and you pump water from there up to the top of the reservoir to store power. That's like a battery. and then you let the water out again and use it to run turbines back into your lake. It doesn't need to be a hydroelectric station, it can be any body of water, and that is to get it back. And that is very efficient. It's 87% round trip efficiency for the best modern pumped hydro storage. And that doesn't involve damming any rivers or anything. And you can also do that same trick with 2 levels of mine shafts, for instance, inside a deep mine, or a deep mine and the surface, and pump water back and forth, or between a lake on the top of a cliff and the sea, and pump water from the sea up to the top of the cliff to store power, and then let it out from the top of the cliff down to the sea to return the power to the grid. So there are many ways to balance the unevenness of solar power and of wind power. So there's going to be no problem. And then people worry about the land area. Well, most of the solar power is solar power plants. They can go on people's roofs. They can go. They can cover roads. They can be mixed with agriculture as shelter for animals and for grass, especially in dry areas. It helps to give the grass a bit of shade. The grass actually grows higher if it's shaded. And so there's no problem with the area for the solar power panels, and there's no problem with area for wind, because the turbines is just a tiny little, the shaft of the turbines doesn't take up much space for your agricultural land. So there's no problem mixing these. And in any case, some of the best places for solar are in the desert, and as long as you avoid the conservation areas of deserts, then there are many areas of desert of low conservation value where you can put solar panels in hot areas. They used to only use solar reflectors, but nowadays, because solar photoelectric has got so low in cost, then it no longer really makes sense to, even for a big power station, to concentrate the sunlight in those large concentrators they used to do. And because these are much easier to install, and they're very low cost now. You don't need to worry about wildlife flying into the mirrors, or being harmed by the concentrating heat, which was a problem with those early concentrating plants, although they found a way around it. So, yes, the renewables is just looking good. There's no problem with renewables. So we can have a rapid transition. And you sometimes hear about how we've got all these coal-fired power plants, and then we're building. These are just the ones that the electricity produced from the currently operating coal power is in blue, and the rest of the world in yellow for China and the rest of the world. And we've got far too much power from coal plants if we're going to go to renewables, so we're going to have to curtail them like that. So you think, oh, that's a horrible problem. We've got wasting all that money of all those coal plants. But what that misses is that the main cost for a coal plant, coal-powered fossil fuel plant, is when it's built. Is not when it's built. Is in the fuel. You've got all the fuel that you've got to carry and truck over to your plant to burn the coal, and that is by far the most expensive part of a coal-fired plant. So if you curtail it here, you're saving all the money on the coal that you would have used for all that bit, and you're not really losing too much, and it makes sense for China to build fossil fuel plants. It did make sense because it just didn't have the technology for renewables, not to roll out at scale, at low cost especially. Renewables were very expensive and they were also not very proven. But now they're so low cost that they can now roll them out at scale. And so they had these very low price to build fossil fuel plants that then very high cost to run. And it made sense for them just to keep the electricity going as they rapidly industrialise. But now, then it no longer is necessary, and we've probably seen the end of the coal plants. Not very many being built now, and so it just makes sense they'll keep these coal plants running, and as they gradually transition to renewables, and they'll use them. They can use them to balance the grid, and while they're putting in the balancing for the electricity. But coal doesn't really balance renewables very well because it can't ramp up and down in the way that renewables need. Gas does. Gas can ramp up and down very quickly, but coal can't. So as we transition to more and more renewables, then the coal plants are just going to be retired early or at less than capacity. So that's what's going to happen there. As I say, I just explain all that there. And we're close to the peak child, and that's another thing. We're peak, and the population is growing because we're living longer. And so this remarkable increase in life expectancy. It's this life expectancy. Look how it's increased that since 1900. Look at that, from 20 or 30 years. Africa. Look how it's increased from about in the early 20th century. Your average life would be 20 or 30, up to now 60 in Africa, which is still lagging behind everyone else. And even in the likes of the Americas, for instance, look how the huge increase in. It's partly because of, it is somewhat skewed a bit because that's partly a lot of children dying when they're quite young. But there is also people living longer. And our life expectancy is increasing. And this sort of shows this share of people living to, so you can see that it's living to 80, 90. So an awful lot of people. So back then, a lot of people died very young. Look, see all those young children dying. That's before age 10. Lots of people dying age 10 in 1851 in the world. That's age 10. So 30% of the children had already died by age 10 in 1851. And now it's way up here. It hardly figures. 2011. And people live up to 20, and I mean, what used to be age 10 in 1851, that's the percentage that die age 70 now. The same fraction of the population that would have died age 10 in Victorian England now live to 70. So anyway, so back to this. So I don't think we want to go. I've talked about this in separate places. So the population is going to peak, but we don't know when. And it very much depends on, for instance, here's Nigeria, and look how it's increasing like that. But it's hard to believe because the highest projections have it having a really vast numbers in China. It's hard to believe, and it's probably going to be less than that. I've talked about it in separate videos, so I won't talk about that there. So anyway, back to resources. You often hear this thing about how when oil is ended, then we're not going to be able to get enough energy from the energy invested in renewables. But actually, I mean, look at hydropower. That's well over 100 compared with oil, gas, natural gas, shale oil. And if you look, nuclear is quite good, but wind turbines are better than nuclear, and they are comparable with oil and gas. And photovoltaic is down there. Remember, photovoltaic is getting less expensive, so it's easier to make using less materials and so on. So these are improving all the time as well. So that's not a problem. Anyway, and there is a possibility of nuclear fusion for the future. That'd be brilliant if that works out, because nuclear fusion is like what the sun runs on. It's different from nuclear fission. It produces much less radioactive materials. So I talk about that. Right. Now, so water, we're not going to run out of water. So all these people who talk about water wars, not true. You do get water problems of rivers with the same countries that share the same rivers, and decisions about what to do with it and so on. So you can get conflicts over water, but it's not because the world is running out of water. But locally, of course, you do get many serious issues, and there's For instance, in India, then they have very significant issues that they're having to deal with because of climate change, which is changing the way that when and how much the Himalayan glaciers melt. The glaciers at the moment are melting a bit more, but in the dry season it's drier. And later on, once the Himalayan glaciers have done their melting thing, which is currently giving them lots of water in the wet season, then then there won't be so much of the ice left up there to supply them with water. So they have to plan forward for that as well as dealing with the dry season. But there are lots of people very clever people working on that. Loads and loads of different things they're doing, and many different schemes that they're working on. And the areas of India that have had the worst issues with water, they tend to be the ones that are best able to cope. It's really the areas of India where they haven't had to deal with this that they then get sudden shock, and you hear all these problems about such and such a city is running out of water because they haven't really prepared in advance. So the big problem in India really is preparing in advance. It's worked out the ways that they can do it. It's quite a challenge, but they can certainly do it. And you talk about the United States, it's not going to run out of water there. And in many places, desalination is already economic. That's the final resort if you need to. And Israel uses a lot of desalination, and other countries are too, the Gulf states. And the United States can certainly use desalination. So that's the worst. We just get it from the sea. It's getting far less expensive, much more economic now. It's already used as a source of water for many people around the world, millions of people. So now to the elements. So if you go through all these elements, then for most of them, then there's actually plenty of the stuff. So for instance, people talk about cobalt and lithium, and in cobalt there's plenty of it, but it just doesn't sell for a high enough price. So that's the problem with cobalt, except in the Congo, where it's a byproduct of copper mining. And part of the problem really is the stability in the Congo. In other places, it's mixed with nickel instead of copper. So the cobalt is there, but you need to have something else in order to make it worthwhile, because it's not worth digging up this stuff just for the cobalt. And nickel isn't valuable enough. But nickel prices may go up because of its value for batteries, and that would help with cobalt there. But they're changing the mix of the elements. So cobalt, it's not a crisis. Cobalt isn't a crisis. One way or another, they're going to find a way. And the same with lithium. They say lithium is a crisis for batteries, but it's not. Most of it comes from this place. But there are many other sources, including getting it from geothermal vines and from wastewater, from shale oil mining into oil and gas mining. Many ways that we can get it. And by the way, when you get people saying things like recently there's a coal mine being reopened in the UK, and people saying we shouldn't go on mining coal. Look, we're supposed to be going down to carbon zero, but we do still need coal. We need fossil fuels. There will need to be some. First of all, we need it for all the fossil fuels that we're going to be burning through to whenever we do reach net zero, which may be 2050, so that's several decades of some fossil fuels. We also need some of it for plastics, and we need coal, for instance, for making steel. Steel is a carbon-iron alloy, so you can't make steel without coal, or something like that, carbon. Maybe eventually you can get it from other sources, but cooking coal for steel is the best way to make steel. And we can make that carbon zero by collecting the carbon dioxide from the flues from the steel plant, which is how they do it in Abu Dhabi already. So we can certainly have carbon zero for that. We can also capture the carbon dioxide and make it into cement, which people are working on already. They use carbon dioxide to reinforce cement. And the main problem is actually getting it certified, because it has to be left and tested for a long time. And the various ideas of not just reinforcing cement, but actually making cement directly from the carbon dioxide. and mixed up with certain I think they're waste materials from ores or something. There's some other materials you have that you need to mix up in order to get this. So and then the rare earths, they're not rare. The main thing is environmental cost. The US has a rare earth plant that it mothballed, and it's reopened recently. And there are many other rare earth deposits if China stopped exporting them. And the main thing is that if China stops exporting rare earths, so China has produced massive amounts of rare earth, mainly because it has less environmental regulations, and it's which is kind of, in a way, not very good. So if China stops exporting them, then we're going to have to pay a bit more for our rare earths, which would take account of the environmental cost, and we would start having more rare earth things that are done properly. And China, because as I say, prices would likely go up. And then some minerals, which we're just not going to run out. There's plenty of phosphorus, for instance. People sometimes say you're going to run out of phosphorus. We actually get tectonic processes are moving more phosphorus up to the surface than we are actually using up. And we have enough for 300 to 400 years in our phosphate rock resources. So there's no phosphorus crisis. And actually, it's mainly because we move things around. Because if we were to recycle, like the animals they excrete nearly the same amount as they eat for phosphorus, can't be lost to the air, not much is lost to the oceans. So it's mainly because we move stuff away, we harvest things, we move things away, and then we need the phosphate fertilizer to take account of that. So there's no fault we can do by reducing the amount that gets into waste. And if the sea is pollution that causes dead zones. And there's lots of progress. So the other thing is that if farmers analyse the ground well, then they can put target amounts in. And that's a big thing that's taking off in the United States, for instance, where they've got a big problem of the of runoff of phosphates in the Mississippi and into the Bay of Mexico. And they are using targeted phosphate to targeting the right amount of phosphate, so they don't put, if you put lots in, then it goes pouring off. You can also, and you can also use seaweed, grow seaweed in the Gulf of Mexico and in other places where you get this runoff. Seaweed is a commercial harvest in China and South Korea, other areas of Asia, mainly those two traditionally, but it's now spreading throughout the world, and they've got it working well and productively in the higher latitudes as well. It was developed originally in those warmer areas, but it's now being used a lot in the upper latitudes. So there's we can have those, and certainly have those in the Bay of Mexico, and there are actually quite a few seaweed plants. So this is growing. You can grow the seaweed in the deep sea. It doesn't need to be even near the shore. And then the seaweed, you can use it, and it's a good place to put it is in these places with low oxygen and the runoff of the phosphates, because the seaweed farms need to be fertilized. So they take this out of the water, and then people can eat the seaweed, and then it can also be turned into fuel. And then it becomes a zero emission fuel. So that's something that's gradually taking off. Then there's I give a link to this. Theo Hankins did a doctoral thesis on scarce minerals, and this is about how long they would last. So some 30 years, 40 years, 80. So antimony, gold for electrical components, and so their antimony can easily be replaced by other flame retardants. And as you went through these things, then the most difficult was molybdenum, which we have 80 years worth of, needed for high-grade steels. And its use is growing as well. So that makes that quite a challenge. And so the main problem with molybdenum is that it's not being recycled, because it's quite cheap to buy, so people are just buying it, using it up, and then it's not getting recycled. And so the article suggested that one way to make sure that our molybdenum lasts a bit longer than that 80 years is to stockpile it to keep the price high, to encourage recycling. And we can also get resources from space. Though molybdenum is rare in space, so this is something I'm actually keen on as a space settlement enthusiast and a space exploration enthusiast. So there's evidence of vast resources of platinum, particularly on the moon. We don't have direct proof of that. It's magnetic evidence, but it's certainly possible that when there was a huge impactor that smashed into the south pole of the moon very early on, way back when there were still big things in the inner solar system before it had been cleared out. A huge thing, I can't remember, it was 100, 200, I can't remember its diameter, quite a wide thing that smashed in, and then the metal core of it splashed out onto the surface of the moon. At least they think that's what happened. So it's probably there for us to mine as we get back to the moon, and it's easier to get low cost things from there. And it's got many other things. I mean, titanium, thorium, potassium, phosphorus, rare earth elements. So then, this is just about GDP. It doesn't have to. So I think that's it. So that's my little bit there about when we have to peak. So it's really only of all these things. He goes into it a great deal of detail, but molybdenum is the only really one that we have to be quite careful, because it's hard to replace by anything else. Because most of the other things he found, they can be substituted by other things. And so it's quite specialist, but it's quite important. So because it's like very, very high temperatures. Of course, it's an important application. Look how its use is growing. So it's not totally untrue, but that seems to be the only example. The lithium, the cobalt, the other things people talk about, then they don't seem to be a major issue. Molybdenum itself is a byproduct of copper mining, and so the problem is that copper also it might need to be reduced, the exports of copper, the production of copper, and that recycled, and then that also means less molybdenum. So anyway, but I'm sure we've got 80 years of it, and we've just got to recycle it, and then we can last much longer.